just give you a little bit of background myself, and what I want to sort of cover a topic off this afternoon is really around project quality and how project quality can affect the schedule, and how the schedule itself, if you've got a good, as far as quality is concerned, how it affects the risks and things like that. So I'm going to walk through with a process and things like that of getting a good schedule in place. And then I'm going to touch on just a bit of a case study, and then I'm going to touch on the tool that supports that process. So that's really what I'm going to talk about this afternoon. But just a little bit of background on me. I suppose I've been around in project controls for the last 30 odd years. Back in the 80s, it was in what we called Artemis in those days, and these days there's a lot of technology out there, so everyone uses different scheduling tools, different types of technology, different platforms. We know we've got Primavera as far as P6 is concerned, Microsoft Project, there's Asta, there's Safran, there's a lot of products out there, and it's, and I guess it's, like, even though the tools are out there, you still need the processes and procedures in place just to make sure you've got good quality schedules. So, and the topic I've got is a good schedule makes a great project, but what exactly constitutes a good schedule? So what makes up a good schedule? And how do you benchmark and standardise on those project schedules against industry standards? So how do we go about that? I'm going to, a little bit about Prescience. So Prescience as a company, we've been around since 2005. Where I suppose we have got an international presence as well, so we've actually set up an office in Singapore, and we're expanding over in the Asian market ourselves at the moment. We've got a very strong partnership with Oracle and Deltek. Oracle from, I suppose, everywhere from the financial components right through to the project controls components. So the Primavera P6, Unifier, risk analysis, Prime, and so on. We've been, I suppose, in that community side of things from the Oracle side. We've had plenty of awards around, the cloud provisionings and setting up P6, and probably the types of customers and things we're dealing with around Australia and now in Asia. We've focused a lot on, I suppose, capital and operation type projects. For example, around Sydney, there's the Sydney Metro project at the moment. We're helping them with their project control system around managing their major contractors around costs and forecasted costs and things like that. So what I want to talk through is, I suppose, just a bit of a framework. And we call this a maturity framework. And at the end of the day, I'll also talk about the tool that supports this framework. But if you look at this framework, it goes through S1 to S5. S1 is, I suppose, the base, so which is really, I suppose, pulling the schedule in and understanding the schedule, and then critiquing the schedule itself, making sure that the schedule itself has the correct logic, it's got the right number of constraints and the right number of critical paths and things like that. Then we'll talk about risk adjustment after that. Once we've got the schedule in place and it's a strong schedule, we can then start applying risk events, and how does that affect that. And then I'm going to talk about optimisation, and what optimisation is about is once I've got a good schedule in place, once I understand all the risk events and how to control those risks, how I can mitigate those risks, the next step is maybe there's ways of accelerating the program, so to optimise the program, which is, again, it's probably more around, like, if I've got some deadlines to meet and things like that, can I shorten the program? There might be something to do with a Christmas deadline or something like that, so how can we pull it back into, before Christmas and things like that. So the goal in this is to really have a good, sound schedule. And what I mean by a good, sound schedule is really the quality of the schedule itself. And if we've got schedulers, is everyone want a scheduler in the room? Hands up, schedulers? How many schedulers? Got a few. And everyone knows that in a schedule I might take shortcuts, I might put leads and lags in, I'll put a constraint in because I can hold an activity out there and things like that. So those sorts of things will affect the schedule and the quality of the schedule, especially if I'm starting to apply risk events and things like that. So making sure that the schedule is realistic and there's realistic, the opportunities and things in the realistic, as far as the schedule is concerned, making sure all those are realistic. Optimising the schedule, so once I run my risk analysis and things onto that schedule, making sure I understand what those risk events will do to my schedule, how I can improve, how I might look at opportunities around those risks and things like that. And the validator, pretty important. Once I've got a schedule in place that you're feeling confident with, you need to get your team confident with it. If your team doesn't support the schedule, they will not be able to progress and update the schedule according to the schedule, I suppose, logic and performance. So it's important to get the team buy-in as well. So basically the goal, by pursuing the 5 levels, S1 to F5 methodologies will help you create a more successful and a more achievable plan. I'll move on. So let's look at quality. And I suppose when you look at quality, you say, well, there's probably 3 points here. The ability to meet the schedule dates. So if I've got a schedule put together and the durations and everything are right in it, the logic's right, have I got the ability to meet those end dates, and is the schedule of good quality? An interesting one here is a poorly constructed schedule, and everyone knows that there's some tools out there, and you can put a simple Gantt chart together, throw some lines on the Gantt chart, put a bit of logic in, and next thing I've got a sheet of paper that gives me some graphical representation of a Gantt chart. That doesn't necessarily mean you've got a good schedule in place. It just means I've got a pretty picture that sits on a piece of paper. And the third bit here is enabling the scheduling tool to work properly as well. So if I've got a good schedule in place, and let's say, my background is probably Primavera P6, and I'll give you some examples here as well. So, I was involved in a shutdown once, and I was working with the engineers and things like that, and they were telling me all this logic, I had to connect this to that and things like that, and I believed them, which is probably something I shouldn't have done. But once we got into the shutdown, I started updating the schedule, and before I knew it, I was getting out of sync logic. I was getting an end date that wasn't meeting the shutdown end date, and I lost sort of sight of where I had to update the schedule. And I went back to the engineers. I says, what have you done to me here? I trusted the logic and everything you've given me, and what they said is their logic was based around managing the resources. So you really got to be careful that the logic and everything you put into that program reflects what you're doing on the project itself. So, what makes up schedule quality? And this is just a few types of measures. I'm not saying these are all the measures, but there's a few types of measures that we could look at. Missing logic. Imagine if I had a schedule there which had a lot of missing logic in, and I started updating the schedule, and before I knew it, I lost sight of the end date. Simply because with missing logic, I'm not going to be able to push other activities in or out depending on whether I've got slippages of other activities that they're dependent on. It's an important component. Logic density. I've got an activity where I've got multiple activities connected to it, and some of those activities may not even be, or should be even connected to that particular activity. There may be reasons that I've connected it, but as long as there's a good reason behind it, that's fine. But so logic density is really, I shouldn't have any more than one going in, one going out, and I don't want any more than 4 in total. So 2 going in, 2 going out. If I start to get too many activities or activities connected to that particular activity, that activity is not going to move until I've completed everything that precedes it. Critical activities. Important to understand your critical path and how much of your project makes up your critical path. If I've got a project in place and 95% of my activities are critical, I've got a problem. So it makes it hard to control the schedule and control that project. So you need to understand that critical path. Hard constraints. A hard constraint is simply I suppose forcing that activity in a certain time frame without the ability to be able to move that activity. Sometimes there's a need for it. You might have a particular project that requires a hard constraint in because I've got to have everything completed for that shut or that window, so therefore I've got a hard constraint of that window, and I'm working to that hard constraint. But don't use hard constraints when you think, oh, probably, I've ordered this bit of kit and it may not get here to a certain date, so I'm going to put a hard constraint in. That's the wrong use of a hard constraint. And if I put hard constraints in and then I do a risk assessment on my schedule, that activity is not going to move. So therefore I'm going to get a true risk assessment of my schedule. Negative float. Gee, if I've got negative float in my project even before I start, I've got a problem. Negative float normally happens is if I've got hard constraints and things like that, and the activities going up to it are pushing the, I suppose, the late dates backwards, showing negative float. And again, it's just, it's not a true schedule, or not a good quality schedule. Insufficient detail. So I've seen some schedules where they put an activity in that's 100 days in length. That's insufficient detail. It's not breaking down those activities enough to actually understand, if I start updating the schedule, how to, or it's not giving you, I suppose, visibility of the end dates and what's causing the slippage of the activities and things like that. So, so insufficient detail is another area. Number of lags and number of leads. So the schedulers in the room here, who uses leads and lags in their schedules? And reason for it? Why can't that be an activity? But true, and people will use curing of concrete, for example, as a lead and lag, right? But they're still activities. There's still risks involved in those. If you're, if the curing of concrete, if it happens to be a lot colder than normal, there's a risk that it will take longer. So you need to build that in. So the number of leads and lags in a project is important to keep them to a minimal. I'm not saying get rid of them altogether, you just need to keep them to a minimal. Merged hotspots. Schedulers, yeah? Yeah, well, you just don't have them, yeah, you just, yeah. Yeah, but that's not, you don't put a negative on that, you should, like it's, yeah. 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 Merge hotspots. This is, I suppose, an area where you might have a milestone, and that milestone is sitting there with a number of activities that need to be completed before you've completed that milestone. Merge hotspots is, some people just have a hanging activity, so they just join it to an activity because they don't want to have an open end and things like that. So you need to understand what those merge hotspots are, because if there's movements in those activities, it could be because I've connected them to wrong predecessors. Well, I've created myself a good schedule. I understand the quality of my schedule, and it's got the right number of constraints, it's got the right, there's no missing logic, I've got a start and end date. Next step is to start understanding the risks that are applied to that particular project itself. So we'll look at risks. You've got a risk could be a threat, could be an opportunity, it could be uncertainty. So basically a threat is might impact the schedule in the non-favourable way. An opportunity might affect the schedule in a favourable way. So it's best to, it's good to understand both those types of risks. Uncertainty is, is all based around the durations themselves. From a schedule's point of view, you'll put your best guess on the duration. From a risk point of view, you might say that this particular activity may take less than what I've determined, or it may take more. And in some cases, there's some activities I might have been aggressively putting a duration in, thinking that, if I can finish it by then, we're going to achieve an end date. But it may slip out 2 weeks as well. So you need to understand those uncertainties in the durations. So, potential events that might cause delays on costs or end dates on the project. So a risk could be incompleted design. Another one could be inadequate site investigations. Yeah, just to give you a few ideas. So each one of these could be risk events. And by determining what that risk event would cost the project in time and value, and also understanding how to mitigate against that risk as well. So capturing all those risk events and then be able to allocate those to the appropriate activities. So we're starting to, what this is doing to your schedule is, once I've actually run a risk analysis tool will do a multi-cal analysis with those risk events on it, I can start looking at by mitigating my risks or unmitigating my risks on that project, what's it going to cause as far as cost and time is concerned. And then I can start looking at, I suppose, where I might add contingencies and things into the project as well. So if I'm actually contracting for a project, I probably want to know what all the risks involved in that project, so I can actually determine the contingencies and things like that. So when do you normally, I suppose, look at running a risk-adjusted program? And I've just listed out a few ideas here as maybe before entering into a funding gate. Let's understand what all the risks and what's it going to do to the schedule, what's the costs, what's the delays and things like that. Before or during the engineering phase of the project. So we're entering into the engineering phase, the design phase and things like that. I still need to understand what those risks are against my project and rerun. A lot of people will initially set up all the risks right at the beginning of the project, and then once they understand the risks, they don't do anything with it afterwards. And I know, there is a lot of organisations that have a good risk register of the risks, but don't sort of monitor those risks through the execution phase. So it's important to understand how often I need to readdress or rerun those risks, or that risk analysis against my schedule. And this just gives you a few ideas of when to do that. Just putting a little bit of a process there. So, first step in the process. make sure I've got a good quality schedule. Making sure that I've got the right durations in place, the logic integrities in place. Then I need to identify the risks. Once I've done that, what are the risks? What are they associated to in the project itself? Then I need to do an analysis on that. Perform a risk analysis. If you walk around there, you'll see there is a number of risk analysis tools. Those risk analysis tools will allow you to capture the schedule, assign the risk to it, run a Monte Carlo analysis. Out of that, you will get some ideas of unmitigated, I suppose, time and mitigated time. You know, what's it going to cost if I mitigate, unmitigate, and what is the difference between my original schedule, so I can actually start looking at where I need to apply contingency factors. So you can do some analysis around that. And optimise. Optimise is really just, now I understand my schedule, I understand my risks, where can I improve my schedule? And you need to do that with the team as well. So it's not just simply sitting in the back room and making some adjustments, decreasing durations by 50%, and then going out to the team and say, right, I want you to deliver this and I want you to deliver it by that date. So you need the buy-in as well. So if I'm going to start decrease durations by 50% because I'm going to put more resources on it, the team needs to know about it. So just continuing down that process, so setting goals. Setting an acceleration goal. You know, like I've got an acceleration goal to complete this project by Christmas. How can I do it? Where are the areas in the schedule I can actually pull back to hit that end date? So setting your own goals. So defining the acceleration criteria, so the action. When changing should be applied during the acceleration. And usually it's, you know, like once I've got an understanding of the schedule and the risks, then I can start applying the acceleration. And you might only apply the acceleration in certain areas of the schedule as well, not the overall schedule. The target set, which activities or groups of activities are you applying the acceleration to? And as simply as I said before, there might be one area you might say, well, in this is an intense labour area, and if I put double the resources on it, I can actually reduce the time by 50%. So it might be just focused on one area. The priorities, what you might have some areas in the schedule that needs some attention to. So, and it might be somewhere around the critical path. How can I apply some accelerations around the critical path? And then you generate several scenarios. So the concept is to be able to generate those scenarios, sit with the team, go through those scenarios, and then select one of those scenarios as the baseline. So that brings me down to the optimise thing. So goal-based acceleration. The benefits, the return on investment. So if I complete this project by that certain date, I'm going to get a return on investment by so much. And in shutdowns and things like that, it's so important to try and complete the shutdown as quick as you can. So you might have a window to fit it in, but every hour it slips outside that window may be costing that company millions of dollars of manufacturing time. Everyone understand the term Monte Carlo simulations? Basically what it means is it will run through a schedule probably 1,000 times, 1,000 iterations through the schedule, taking one is, if I'm just looking at my duration uncertainty, taking your min, max and most likely durations and plotting it out on a chart. The same with, and once I add risk events to it, I'll rerun it again. So that's Monte Carlo simulation. Optimisation isn't really what I'm talking, it's not using that sort of scenario. Optimisation is focusing on the schedule, parts of the schedule, and how I might be able to accelerate the schedule in certain areas. So it's not running a Monte Carlo analysis on the whole schedule itself. Yeah? I'm going to touch on a little bit of a case study. So what I've talked about is really a process. It's having a good quality schedule, understanding the risks, running the risk analysis on it, understanding where I can accelerate it, selecting that particular project and saving it as a baseline. That's the process, so just keep that in the back of your mind. Right? This case study here is a case study put up by Deltek, so Bombardier Transport, over 70,000 employees, they're headquartered in Canada, they're multinational manufacturer in planes and trains. They're doing a large modernisation project up in Canada at the moment. They've got multiple planners working on it, so multiple schedules. The activities within each of those schedules are growing, and I think it says a little bit later on there's probably over 10,000 activities. And the logic is very complex. What they're trying to do is they're trying to implement scheduling best practices, right? So good quality schedules. They want to do quality checks and the ability to analyse the quality of each sub-project within that overall master schedule. There's internal customisation provides standard checks, schedule quality. So they've got, so I went through a number of schedule qualities before, but a lot of organisations that we've dealt with want to have their own schedule type metrics in place. And one of my examples, even in Australia, is Sydney Trains. So Sydney Trains, they're subcontractors, and it's written into their contract that the quality of their schedules need to meet a certain metrics, and they've written their own metrics around what they expect their subcontractors to submit to them. Clear communication, use of an analysis report to understand where there are issues in the schedule itself, and to, I suppose, have the ability to correct those areas as well. And now I'll probably get on to what product will support that, so touching on technology. So the technology I'm going to touch on is a product called Acumen. Acumen is a Deltek product, and there's three components in Acumen. First component is Fuse. This company here has decided to implement the Fuse component because it fits some of the requirements around schedule quality. So Fuse has a number of metrics that comes with the product, but they've tailored those metrics to meet their internal standards, so they can start running their schedules through that standard metrics to understand that it meets a certain quality. How long have I got? Great. Reporting wise, so like if you're using a scheduling tool and you're the person that needs to make sure that it meets a certain quality, and if you've got a 10,000 line program to run through that and running reports and things like that, you probably could work out where there are issues in that schedule, but I can guarantee you it won't take you 5 minutes. So the outcome. So they've leveraged Acumen Fuse. The activities that they're doing their analysis on are 10,000 plus activities. They understand, where there are schedule qualities. They understand where there are changes in the updates from one schedule to the next, so they can quickly identify what changes were in one schedule to this month's schedule. And the automated analysis and reporting from the system allows them to quickly correct those areas and bring it up to their level of metrics. So I'll just run through a little bit of Fuse just to give you a bit of a flavour. So in Fuse, as I said, there's three modules. Or Acumen, there's three modules. Fuse, this is Fuse here. And Fuse is really around advanced analytics on the quality of the schedule. So it does have a number of metrics in there, whether you're looking at for example, just schedule quality, but I could also look at where are the changes from my baseline to my current schedule. So I can actually pull the two in and do a comparison very quickly. Unique features, the logic analysis, the forensics, benchmarking. Benchmarking is really where they've got other projects stored, or I'd say indexes from other projects stored that you can compare your project to make sure that you're meeting the same needs as whatever, or the same sort of indexes as what other people are doing around the world. That's probably a bit of a messy screen, but it's simply pulling a project in, and I've actually broken it down by the work breakdown structure there. And on the right-hand side there is really the different metrics with a score at the end. So, so if I roll that up to a project line, I can get an overall score. And I know some organisations in their PMO now are running their project schedules through this to make sure that it meets the quality of the organisation. So, and then they also remeasure it on a monthly basis to make sure there's no deviation from the score that they're getting. This is just that where I said that they can compare their metrics to other standard metrics of other projects around the world with the similar characteristics as well, whether it be a construction project or a hospital project and things like that. Just a dashboard of the same results. This is just a forensic side, so this is as I'm pulling in my monthly schedules, I can quickly identify where are the changes from one schedule to the next schedule, whether it be duration, whether it be additional activities or logic changes and things like that. So it just allows you to do forensics quickly on the project itself. Risk analysis, all in the same tool. The nice thing here is I've brought the schedule in, and once I've done the quality check from the same tool, I can then start collecting the risk events, assign those risk events the activities, and do my Monte Carlo analysis, risk analysis on those projects themselves. Out of that, I can start looking at what are my uncertainty drivers as far as duration is concerned, where my I suppose my distribution as far as, and you've heard the terms P80s and P50s and things like that. So if I've got a P80 schedule, what does that look like? That's the, and that P80 schedule could be your baseline. Nice screen here is really telling you each activity and what are the risk drivers within each in each of those activities, and how much that risk driver is affecting that activity. So in some cases it might be pushing that activity out by 10 days if that risk happens. Your risk register, so this is where you capture your risks, capture your mitigations against that, and how I can mitigate those, and I can do step processes, and it could be even, a risk could be weather, for example. We know it's going to rain at this time of the year every year, so I need to capture that as a risk. How does that affect my schedule? Optimisation. So optimisation is all around, once I've got a good schedule in place, I understand my risk, I can then start doing some analysis of where I might be able to accelerate the schedule. And they might be in certain parts of the schedule, and this tool actually allows you to do, I suppose, perform sort of checks on different areas and run steps against the schedule, and out of that I might get a number of scenarios, and then from that I can then share those scenarios with the team, and then we can agree on which scenario best fits and what we're all prepared to work with, and we save that as a baseline. Again, yeah, like you'll see here is, so this particular part of the product is called 360, but it allows me to sort of indicate, you know, areas of where I want to be aggressive in those scenarios or those accelerations, and by using slide bars. Running an acceleration process on it, which is taking that information I've just provided it and setting an end date and whether I can achieve that end date, which then creates a scenario. So it's not affecting your existing schedule, but I might run through several iterations of this. And this is where you can actually define the steps on those accelerations. So in other words, this one here might be remove hard constraints, accelerate the construction area. So just looking at the construction area. So I'm just making sure it's going to remove any hard constraints there, change the acceleration around those, and then I can run an analysis on it. And I'm finished on time. Any questions? Does it all make sense? I'm out in the booth if you want to come around and have a look at the product in any detail as well. So I'm quite happy to take more questions out there if you want to come over and go into any detail around the product. So. Yes, mate.
Hi. So you obviously, I know that you do a lot of work with companies, small, medium, large, etc. Yep. And you mentioned the quality of schedules varies. Have you noticed any trends of what's causing this variance in quality, or any common trends? Is it lack of training, lack of knowledge?
Lack of
process. Yeah.
The tool allows you to be.
Yeah.
Allow you to, like I suppose, just put in activities anywhere and things like that. So the tool doesn't sort of, I suppose, push you down a sort of quality track. Yeah. So all those and above. And like I could, there's a few organisations. You take Microsoft Project for example. Microsoft Project, I can get in there and draw a bar, put it anywhere I like. Draw another bar, put it anywhere I like. Yeah. And because they've never been trained around understanding a schedule, they don't understand what logic and everything is. Yes. They just know that if I draw a Gantt chart, I'm a project manager. I didn't mean like that. But like at the end of the day, I'm a scheduler. And that's what happens. So the tools don't force you down that track either, because there's nothing stopping you just drawing. Excel, you can get in there and draw, pretty bars on an Excel chart, put some dates on top. There's my schedule. Okay. So tools also don't help you either, but everything above. So some of the ones that are successful, if they've got a PMO office, they put in standard processes and procedures.
Yes.
They've got a training regime in place, and they've got standard tools, because some organisations will buy Microsoft Project, Asta, and all the other tools, but there's no standard reporting and things like that. So all that adds up to sometimes poor quality schedules. Okay. And I guess also a poor quality schedule can come from. So it's not. This is just checking your schedule, by the way. It's not checking the content of the schedule either. It's just checking the schedule. So I'll just be clear on that. Oh, thank you for listening in, and I hope you got something out of it. So.